Castings, I'd like to have a casting block that could make, say, 100 Matchbox cars all at once. Maybe we just go real big with it. We already have what feels like a casting cathedral back there, so why not? Let's see how far we can push. The limits of physics, how large can a casting machine really be? Let's find out. If you're still thinking that the electric car competition is about battery size or how far a car can drive, you've already missed the point. Now, it's all about how quickly a car can be built, and Tesla is leading that race. At Giga Texas, Tesla is casting an entire car frame in just 3.75 seconds. That's right, the 50,000-ton Giga Press is creating the full body of the Cybercab or Model 2 in under 4 seconds. This same process is expected to cut the production time of the Model Y and Cybertruck to under 6 seconds, helping Tesla put affordable self-driving vehicles on roads as early as next year, while other automakers are still busy welding together hundreds of separate pieces. Tesla's fully automated process works in an area where no people are allowed. Robots and AI handle everything, from preparing the mold to inspecting the final product with X-rays. So what does a Tesla car built in just 3.75 seconds look like? Is it real or just another bold marketing claim? Welcome to Tesla Car World. How? Does Tesla actually manage to build a car this fast? Maybe the answer is just to build even bigger casting machines. Why not? At the center of Tesla's Giga Texas, a full car body is being formed every 3.75 seconds. If you walk through Giga Texas or check out the Model 2 and Cybercab production lines, you'll see this isn't just a claim, it's real automation. Unlike anything the auto industry has seen before, this is not about assembling a car step by step. It's a new way of building, where a car's frame is created all at once from a mold. The 3.75-second casting process might be Tesla's most jaw-dropping achievement so far. It doesn't just speed things up, it also makes the whole process easier. When you cut down the number of parts in a vehicle by 60 to 70%, you're also reducing costs, chances of failure, maintenance needs, and warranty issues. Logistics, storage, and repairs also become easier and faster. Elon Musk has often compared Tesla's new production lines to giant toy factories, and he wasn't just speaking poetically. Tesla is taking the same kind of die-casting tech that was once used to make small toys and is now using it to build electric vehicles at scale. Each time the Giga Press cycles, 5 chassis for the Model 2 or Cybercab could be produced within a week. Just one facility can create hundreds of thousands of cars per year, using fewer workers and taking up less space than any traditional car factory in history. The backbone of this innovation is the 50,000-ton Giga Press, the most powerful die-casting machine ever used in the car world. The earlier machines, rated at 6,000 and 9,000 tons, already changed the game by merging 70 to 100 parts into a single aluminum piece. But this 50,000-ton version operates on a completely different level. Molten aluminum, heated to about 850 degrees Celsius, is pushed into a massive mold shaped like the car's underbody. The pressure is so powerful, it could flatten a steel barrel instantly. And the speed? It's not just quick, it's shockingly fast. From the moment the aluminum is injected to when it solidifies, is pulled out, and the cycle restarts, the whole thing runs with incredible precision, like a perfectly timed dance of heat, pressure, and automation. It's an industrial ballet, but there are no human dancers. The Giga Press and the area around it are completely off limits to people. This isn't just for safety, it's necessary. With molten metal, intense heat, hydraulic force, and fast-moving parts, it's a place where humans can't work safely. Instead, robots manage the process from every angle, while technicians sit in safe rooms behind thick glass, watching screens, and monitoring everything with sensors and AI systems. This doesn't look like an old-school car factory. It feels more like a mix between a robotics lab and a space mission control room. What really takes this process to the next level is how Tesla combines this mega casting with 3D printed sand cores. These sand cores are special molds made using binder jet 3D printers. They allow Tesla to create hollow spaces inside the aluminum casting for things like wiring, cooling systems, and internal channels. Once the aluminum cools and hardens, the sand is removed, leaving behind these built-in features. This technique, which comes from aerospace and precision manufacturing, means Tesla can pack more features into each cast and cut out dozens of parts that used to be added later. By skipping many of the steps that traditional automakers rely on in designing cars for casting from the start, Tesla is now building vehicles more like how smartphones are made pre-assembled, simple and built entirely by robots. Each casting cycle is a self-contained process. The mold gets sprayed with soybean oil to keep things from sticking. A vacuum clears the air inside, molten metal is injected quickly, and the part is cooled through channels that match its exact shape. Once it's cool enough, the part is ejected while still glowing, then dipped into a cooling bath. A robot trims off any extra metal, checks for defects using X-rays and AI, and gets ready for the next part all in under 4 seconds. If just one Tesla factory runs 2 presses at the same time, a complete car frame could be made every 1.875 seconds. This isn't just mass production, it's extreme production, but as amazing as it sounds, it's not without challenges. Casting metal at this scale needs extremely accurate heat control. If the aluminum is injected too fast, air bubbles form and weaken the part. If it's too slow, the metal cools down too early and doesn't fill the mold completely. The molds themselves are exposed to rapid changes in temperature. Hot aluminum followed by cold water hundreds of times per hour. Just designing and caring for the molds is a full-time job for a team of engineers. Removing the sand cores cleanly is also tricky, especially when they're deep inside the part. Still, Tesla is determined to keep scaling this technology. While other automakers like Hyundai, Volvo, and GM are starting to use 16,000-ton casting presses, Tesla has jumped far ahead. This change from welding metal to casting large single pieces isn't a slow evolution. It's a sudden shift, like going from analog to digital. Tesla's journey into Giga casting started with the 6,000-ton press. That machine changed how the rear chassis of the Model Y was made by replacing over 70 separate parts with just one solid aluminum casting. It was a bold move in the auto world. Then came the 9,000-ton press for the Cybertruck, which handled even bigger, more complex parts. Now, the focus is on something even more disruptive: the 50,000-ton Giga Press. This huge machine isn't just producing more, it's doing it at record speeds. What used to take minutes or even hours now takes less than 5 seconds. Based on recent reports from Tesla staff, the Cybercab chassis is now being cast in as little as 3.75 seconds. That's from liquid aluminum to a finished car frame. Even Elon Musk was surprised by the speed at first. But the results are real. Tesla's production system isn't just quick, it's resetting the entire pace of modern car manufacturing. 1 Giga Press can now make over 900 car frames an hour, a massive jump from what even the most optimized factories can do. Tesla's system has become the fastest large-scale EV production setup in the world. So what makes this machine so different? The 50,000 tons refers to the pressure it applies to hold the mold shut, not its weight. But the press is still gigantic. It weighs over 8 million pounds, stretches more than 130 feet long, 40 feet wide, and stands taller than 30 feet, about as tall as a 4-story building tipped over. Setting it up takes months and needs a strong foundation to handle the vibration and heat. Inside, Tesla uses 2 types of furnaces, one gas-powered to melt aluminum at 850 degrees Celsius, and one electric to keep the metal at the perfect temperature. Nitrogen is pumped in to stop the metal from oxidizing, and gas systems remove impurities before the metal goes into the mold. The mold is sprayed with soybean oil before each shot to keep things clean. A high-speed piston pushes the aluminum into the mold, and a vacuum removes trapped air. Cooling channels follow the mold shape to cool the part evenly and fast. Within 3.75 seconds, the part becomes solid and comes out at 400 degrees Celsius. It's dipped into water to cool it to 50 degrees Celsius. Then robots cut away extra metal. Check for quality with X-rays. And get ready for the next shot. Tesla has even made smart molds that track pressure, temperature, and flow in real time. AI systems use that data to make sure every part comes out perfect and fix issues before they become defects. Right now, Giga Press is mostly linked to cars, but other industries are watching closely. As more companies see how it's helping Tesla make cars faster, stronger, and cheaper, the real question is no longer whether others will copy, it's how soon. That might be the biggest sign of Tesla's success. It's not just about electric cars anymore. It's about changing how the world makes things. So if Tesla can make a car frame in just 3.75 seconds, why are traditional car makers still spending hours welding hundreds of parts? And if Tesla figured out how to print a car every few seconds, what's stopping the rest? Let us know your thoughts in the comments. Thanks for watching this video. If you'd like to see more cool updates about Tesla EVs or Tesla bots, please hit like, share the video, and subscribe to Tesla Car World. Don't forget to turn on the bell so you never miss a new post. We appreciate your support. See you in the next video. Goodbye.